questions were revolving around graphing. People were asking me to do a little demo on graphing, more than what we already saw. So here's what you have to know. This is my basic equation. I want to know what's the A value. B, if the B number is greater than 1, it's growth. I want to look and see if there's an H, either added or subtracted to X. And I want to see if there's added or subtracted a number on the back end, that's my K value. These are the rules, okay? If A is negative, that means that the graph is a reflection. So that means instead of going up here in quadrants 1 and 2, it's down here in 3 and 4. If X minus H is available up there with numbers plugged in, that means you're going to move to the right, whatever the number H is. Right 1, right 3, whatever it is. If it says X plus H, that means you're going to move left H units. So again, whatever that number might be, you're going to go left. If it says add K, a number added that's the same size in font as like the 3 in this example, that would mean you're going up. And if you have minus K, that means you're going down. So let's just take a basic parent graph. I'm going to use y equals 3 to the x. And I took 3 numbers, a negative, 0, and 1, and I'm going to plug it in for x. So if I put negative 1 up there, 3 to the negative 1, that makes 1/3, okay? What about 3 to the 0? Anything to the 0 power is 1. What about 1 for x? That's 3 to the 1st. That means you have 3 one time, so that's 3. Let's go plot these points. Negative 1 is at 1/3. 0 is at 1. That's my y-intercept. They asked that a lot in the questions. 1, 3 is right here. So the graph looks like this. It is approaching the x-axis, but it's not crossing it or touching it. So you have to make it look like you're trying to get closer and closer. When this type of line exists, that the graph approaches and it's not crossing, that line is called the asymptote. In my example right here, the asymptote is y equals 0, because all horizontal lines begin with y equals, and 0 because that is the line for the x-axis where all of the y coordinates are 0. And that's the parent graph. So let's go talk about what if it has a negative right in front of 3 to the x. That means that you have negative 1 times 3 to the x value. So we're going to go plug in some x values there. Let's use negative 1, 0, and 1 again. If I put negative 1 in here, 3 to the negative 1, that's 1/3 times negative 1. Negative 1/3. When I put 3 to the 0 in, that's 1 times negative 1. And when I put in 3 to the 1st, that's 3 times negative 1 is negative 3. Now if I go plot those points right here on the same graph where I put the parent, okay, that means that I'm going to have this 0, negative 1, and 1, negative 3. And that's why negative 3 to the x looks like a reflection of the blue graph. Flips straight across the x-axis. So what would I do if the graph said, go plot a graph 3 times the power of x minus 2 plus 4? That means that I'm going to move the graph to the right 2 and up 4. So I'm going to take any point on the parent graph and I'm going to move it right 2 and up 4. 2, 3, 4. And so this point would go right 2 and up 4 as well. So what would happen with this point down here? Well, he's going to do the same thing. Right 2 and up 4. So what you have noticed now is the actual x-axis has moved up 4 as well. This is called a translation, when you slide all the points right and left. And so now the asymptote is y equals 4. So whatever the k is, that's the asymptote's equation, y equals 4. The final one, y equals 3 to the power of x plus 2, subtract 4. Since it says x plus 2, that means I'm going to move left 2. And since it says minus 4, I'm going to go down 4. So I'm going to go back to the parent graph. Let's use the y-intercept. And let's move it left 2. And then go down 4. I'm also going to have to move the asymptote down 4. Oops, sorry. I'm trying to do this sideways. And so my graph looks like this. I would take each one of the points from the parent graph and count them left 2 and down 4. And that would be the shift to the last graph.